In this fourth video, we're looking at a way of improving our estimate. So in the previous video, we considered the compressor, that we identified two distinctive failure modes. We have a mechanical failure mode and a seal failure mode, and we combined those by a model called a competing failure mode. We combined them, and we had the two failure mode. One was the mechanical, one was the seal, and we had the resulting one. The resulting one, which said it was the combination of these two failure modes, and mathematically is the product of the two. And say, for example, we wanted to present a 95% reliability or a 5% probability of failure. After how many hours we get these results. And we could go and latch onto this blue line and try to find roughly the coordinates of that, 5,900 hours roughly. So, or we could just verify this value with a quick calculation pad, a B5, 5,900 hours. Okay, but there is a problem with this value. This value is a median value, and therefore it has a 50% margin of error. And that's quite difficult to accept, in so much that if we collect more data, there is a risk, there's a 50% risk that the value may change, it may drop below 5,913 hours. And therefore we need to find a way of protecting us against something like that. And that level of protection is called confidence bound. And to make things a little bit tricky, there are different types of confidence bound. There are two-sided confidence bound or one-sided confidence bound. So, and if we look at one of them, one example, associated with a confidence bound, there's always a confidence level. In this case, set at 0.9 or 90%, but it's arbitrary. So a confidence level gives us a probability or a likelihood that the value we are looking for, say in this case the B5, is contained between a lower value and an upper value. So in other words, as we say in video number 1, our analysis is going to be an estimate because we'll never know the true results of our data unless we're prepared to wait for all the product to be broken and then we can analyze. But as we are likely to work with samples, we're using confidence bound in situation where our data is preliminary, so we don't have a full amount of data that we would like. But we still need to make the most accurate prediction that we possibly can. And so here we're saying that we are 90% confidence that our B5 live is included between these two extremes, 3,100 and 11,200. This may not be the most appropriate type of confidence setting for this type of analysis. In fact, we may want to explore the lower one-sided confidence bound, and we can change this setting if we think it perhaps is too restrictive. Say we could put it perhaps to 80% confidence bound. And what we're saying here, we're saying that we are 80% confident, so we are prepared to take a margin of error of 20%, and we can decide whether they're acceptable or not. But with regard to this analysis, we are 80% confident that our B5 live is above 4,250 hours. That's what we're saying with this statement. So in effect, we're not even considering the median value here with this statement. We are mainly focused on the lower confidence level, lower one-sided confidence level. And as we say, we're using this type of analysis in situations where we got very little data. So we are taking, for example, this electronic board. We have 3 failures and 12 suspension. So we have a very high variability data with a lot of uncertainty because we still got 12 suspensions. So when we analyze our projection, we see that we have a very wide confidence band. We have very wide confidence band because obviously the high level of uncertainty. And if we compare, say, a median value result, for example, a B10 live against a more pessimistic result, we see the difference is considerable. But the width of the confidence bound is not only dependent on the number of data points, certainly plays a strong part in it. But if we look at this data set, for example, here we have 6 failures, but if we change one of these failures, we can see immediately how the projection changes. So we haven't actually changed any of the other numbers, we've just changed one failure, which was making the model very imprecise, if we want. And this is because not only depends on the data points, but it depends on the variance. So in video number 5, we'll be looking at what kind of information we can get out of our graphs in terms of multiple failure modes and so on. So thank you for watching, and see you on the next video.